Hello, everyone. My name's Mr. Minnick. Sorry about the delay in the sound there. Uh, Mr. Minnick's my name. Math is my game. I'm joined today by one of my Algebra 2 classes, and here we are, fractions, part 2 of 2. In this lesson, we'll be looking at how to order fractions, as that's going to be an item on the upcoming test. As you can see, we're going to be looking at adding and subtracting fractions where we have mixed numbers, and we're going to include in that a discussion of borrowing. The third item is cross-cancellation and cross-multiplication. A lot of people confuse those two. So we're going to be discussing that. We're also going to be multiplying and dividing fractions. So that's kind of a roadmap of where we're heading in this. So I guess we ought to start with ordering fractions. Ordering fractions, some textbooks tell you to get the denominators the same. My best suggestion is, you probably know some decimal equivalents, and my suggestion is try to get decimal equivalents. Now, my Algebra 2 classes are going to be taking a test where they're not allowed to use a calculator. So that's going to kind of pose a problem to some of them. But let's just look at an example and see how we could do this. Example 1. Arrange from largest to smallest. Arrange from largest to smallest these fractions. We'll go with 5/8, 1 hizzy, 3/5, and 7/16. All right? So of those fractions, there's one of them that you should know the decimal equivalent of without any question. And that one would be 1/2. Good. Yeah, 1/2 has a decimal equivalent of 0.5. I'm hoping that everybody's clear about that. Now 5/8, you might not know it, but if you do a little bit of thinking, you could figure it out. 5/8 is a little bit bigger than 4/8, and 4/8 is equivalent to 1/2, right? So is it fair to say that this is greater than 1/2 for now? And we might come back to that, okay? But it's bigger than 1/2, right? Now 3/5, you're probably looking at that and say, I can't make that a decimal. Well, that should be pretty easy. Let's turn it into tenths. If we multiply by 2/2, it's 6/10, and 6/10 is 0.6. Is that easy enough? Okay, so 3/5 then is 0.6. Now 7/16 is close to 8/16, and 8/16 would be 1/2, right? So 7/16, is it fair to say that it's less than 1/2? Okay, so it's less than 1/2. So really, there's only one that's screwing this up. So if we had to arrange this, we had to write our answer, I guess we would start with the smallest one, which is 7/16. Oh, largest to smallest, crap. So I guess I'm going to put 7/16 on the other end, and I'm sorry I said crap. Maybe I should have said a different word. Oh no. So what would be next to 7/16 then? A hizzy? So now the question is, well, what do I put first? Do I put 5/8 or do I put 3/5? Which one's bigger? We think 5/8 is bigger? Well, let's think for a minute. You might not know what an eighth is, but you know what a fourth is, right? 1/4 is 0.25. Or if you think in terms of baseball averages, it's 250. That's actually going to make this a little bit easier to think of it that way. Okay? Half of a fourth would be an eighth. Half of a fourth would be an eighth. So an eighth is going to be half of 250. What's half of 250? Half of 250 would be 125. Okay? So if we think about the number 5/8, 5/8 is 500 and then another 125 on top of that, right? So 5/8 is 0.625. So in order then from largest to smallest, we would have 5/8, 3/5, 1/2, and 7/16. Okay? What do we think? That's not so bad, is it? Okay. On the test, a lot of people, if we end up doing the longhand test where you're writing everything out, a lot of people will miss this question because they misread the directions. They're accustomed to arranging things from smallest to largest. Okay, so, all right. Well, let's take a look at the next item up for bids, and addition and subtraction with mixed numbers. Adding and subtracting mixed numbers. I used to suggest with these to make them improper fractions, but that's a lot of work. That's really a lot of work. What you can do is add the wholes and add the fractions. You can add the wholes and add the fractions. Now, when you add the fractions, sometimes the fraction's going to be an improper. If it's an improper, if you get an improper, then you get more wholes. And we'll see what that's all about here in a second. But if you end up with an improper, you get another hole or maybe a couple more holes. I don't know. It depends on the nature of the fractions. Okay. So we'll look at some examples. And I did tell my class that on the second worksheet that there was a worksheet 1 and worksheet 2. There's some items on there that have adding and subtracting mixed numbers. I'd like them to try that tonight for homework. So let's look at example 2 then. Example 2, 8 1/5 plus 7 3/5. Okay. 8 1/5 plus 7 3/5. This one's not bad because we have like denominators. So when we add the wholes, how much do we get? When we add the wholes, we get 15. When we add the fractions, how much do we get? So we get 15 4/5, and that's it. That's pretty easy. Add the wholes and add the fractions. So far, so good? Well, let's try another one. Let's try 7 3/8 plus 1/4. Now, we don't have like denominators, but we should remember from yesterday how to get a like denominator. Our LCD should be what? 8. So what we're going to do to the 1/4 is multiply by 2 over 2. So what we've really got is 7 3/8 plus 2/8. So this is going to give us how much? 7 5/8. And that's it. How are we doing so far, okay? So let's ramp things up a notch. Let's try example 4. Let's go with 3 7/8 plus 2 and 2 9/16. Ooh. What should our LCD in this instance be? It should be 16. So what we're going to have to do to the 3 7/8 is multiply by 2 halves to get our LCD. So we're going to have 3 14/16 plus 2 9/16. So when we add the wholes, how much do we get? Well, let's just add the wholes first. We'll worry about making more holes here in a minute. We get 5, and then when we add the fractions, how much do we get? 14 plus 9 gives us how many sixteenths? 23/16. Okay. So Houston, we have a problem. 23/16 is an improper fraction. So that means we're going to get some more holes. And this is where people really have a hard time thinking outside the box. 23/16 could be written as 16/16 plus how many more sixteenths? 7 more sixteenths. Okay? And if you can't think that way, then you're probably going to have a hard time doing what we need to do with this. But you got to realize that 23/16 is 1 7/16. Okay, so this is really like 1 7/16. So what that means is rather than having 5 23/16, we're going to get one more hole out of it. So we're going to have 6 and how many sixteenths then? 6 and 7/16. Okay, I know one like that's a little bit tricky. There's probably only going to be 1 or 2 like that on the test, but there will be 1 or 2 like that. Okay. Are there any questions at this point? Well, we really need to try subtraction, because with subtraction, sometimes we need to borrow. Let's go with 8 and 1/7 minus 5 and 17/21. Okay. So what should our LCD be in this instance? 21. So we're going to multiply by 3 and 3. So we get 8 and 3/21 minus 5 and 17/21. So here's where we need to talk about borrowing. Borrowing. Some people pronounce that word funny. They say borrow. But we're talking about borrowing or borrowing. In this case, you can't really subtract the wholes yet, because in order to be able to subtract the wholes, you have to have the fractional part in. The fractional part here has got to be bigger than the fractional part there, and it's not. So we can't subtract the wholes yet. So we don't have 8 and 3/21. And this is where people don't like this. You have to kind of be able to think outside the box again. 8 is really 7 plus 21/21. Does that make a little bit of sense? Okay. So then what that means for us is 8 and 3/21 could be really thought of as 7 plus 21/21 plus 3 more 21. Does everybody see where I'm going with this? I know it's kind of confusing. Okay. So that's really 7 and 24/21. Okay. So what I've really got is 7 and 24/21. This is called borrowing. Okay. When we do that, then we're going to be able to subtract the wholes from the wholes and the fractions from the fractions, and life is good. What's 7 minus 5? 7 minus 5 gives us 2, and 24/21 minus 17/21 gives us a total of how many 21sts? 7/21. Now, are we done with this problem? This one worked out really nice. Really, really nice. Oh, we can reduce. And I did say that on the test, if you can reduce and you don't, I will mark it wrong. So 7 and 21 are both divisible by 7, so we can reduce this, right? So we get 2 and 1/3 there. Okay. Now I know somebody out there is thinking, well, I'm just making this crap up. There's no way that that's right. So, and I did tell you that I would show you how to do these things on your calculator. But why are you showing us? We're not going to use it on the test. No, you're not. But at some point in the future, you might have to punch one of these in your calculator for whatever reason. Maybe you forget how to do this in a week. Hopefully not. 8 and 1/7. So notice how I put that as 8 plus 1/7 minus the quantity of 5 and 17/21. Now 2 and 1/3, let's think about that. What's that as an improper fraction going to be? Wouldn't that be 7/3? Because this is going to tell me 7/3. Okay. Actually, it's going to tell me 2.3333333333, unless I tell it to tell me a fraction. So it's 7/3. Or if I don't tell it to make a fraction, it's 2.33333333. Okay. So it's legit. It's for real. It works. Let's look at another one like that. Example 6. Example 6. 3 and 1/8 minus 1 and 3/4. Okay. So we're going to use what for an LCD? 8. So we're going to multiply by a 2 and a 2. So we're going to have 3 and 1/8 minus 1 and 6/8. Houston, we have a problem. We don't have enough eighths in that first fraction, so we got to borrow. So again, 3 is kind of like 2 plus 8/8, right? And you don't have to write this. You just kind of have to be able to realize where it comes from. So 3 and 1/8 is like 2 and 8/8 plus 1 more eighth. So that's really 2 and how many eighths? 2 and 9/8. Okay. So it's going to turn into 2 and 9/8. So we've got 2 and 9/8 minus 1 and 6/8. And then we could subtract the whole from the whole and the fraction from the fraction. And what do we get? We get 1 and 3/8. Okay. So this this video will be up on the line on YouTube. I'm sure there's all kinds of resources out there with subtraction by borrowing. Check it out. It's legit. It works. There will be a couple of these on the test. Okay. So if I'm not mistaken, we're done with 2 of the 5 concepts that we said we'd look at today. Ordering, we got that. Adding and subtracting with mixed numbers, including borrowing, we got that. We ready for this next segment? Well, this next segment is near and dear to my heart. In educating people in mathematics, I really wish that everybody knew the math vocabulary that I did. Now, if you don't, by some chance, if you don't, what I would recommend doing is checking out this webpage. It's called mathwords.com. Mathwords.com. Mathwords. Not mathwads. Mathwords.com. I wonder what mathwads would look like. Would that be like spitwads? It'd be all kind of crumbled up equations that, okay. So, I wonder if they have anything in here under cross cancellation and cross multiplication. I just put a blue dot on the C. I didn't mean to do that. Cross, do they have anything under, oh, Kramer's rule, that's a good one. They have a cross product, but they don't talk about cross multiplication here and cross cancellation. That's kind of disappointing. I've got news for you about these two. They're not the same. Cross multiplication and cross cancellation are 2 different things. And people want to mix them up, just like they mix up factors and multiples. Cross multiplication is legit. It is. I've been using that word today. Maybe we need to listen to some MC Hammer. Too legit to quit. Cross multiplication is a legitimate mathematical idea, and it is very useful when solving a certain kind of equation. When you have a fraction equal to a fraction, what's that called? Starts with a P, and it ends with an N, and it has another P in it. Starts with a P, ends with an N, and has another P in it somewhere. Thank you. When solving a proportion. When solving a proportion. That's when you use cross multiplication. Some people think you cross multiply to multiply fractions. No, you don't. Cross multiplication is used when solving a proportion. For instance, if you had a proportion like 3/16 is 27 over x. There's actually more ways than one to solve this, but anyway, the way that you're probably shown to solve this is cross multiply. So you get 3 times x equals 16 times 27. And so x is 16 times 27 all over 3, whatever that is. Who knows? Okay. I solve proportions a little bit different than most people. But anyway, that's useful, finding the cross products like that. Okay. Cross cancellation is useful when multiplying fractions. And this is where it gets confusing. What are you talking about? Why wouldn't you use cross multiplication when you multiply fractions? Well, because you don't. Math doesn't make any sense. Well, math does. Sometimes the vocabulary gets confusing. It's just like the English language. Sometimes vocabulary gets confusing. Your, and your. There, and there. 2, and 2. They're all the same. No, they're different. When you multiply fractions, you should cross-cancel if possible. So I want to say this about cross-canceling. Regardless regardless of their location, numerators cancel denominators. I almost got that wrong. Regardless of their location, numerators cancel denominators. And I can say that phrase the other way around as well. And I will. Regardless, not irregardless, but regardless of their location, denominators cancel numerators. Regardless of their location, numerators cancel denominators. Denominators cancel numerators. And I want to be as clear as mud on this. Numerators do not cancel numerators. Similarly, denominators do not cancel denominators, and this is why it's called cross-canceling. And some people get this idea really, really messed up. So denominators do not cancel denominators. This is a lot of writing about these stupid cross-multiplication or cross-canceling. I mean, anybody in here in a science class? In a science class, I'm more than positive that at some point you had to convert milligrams to pounds, or maybe feet per second into inches per mile, or not, that wouldn't make sense, inches per hour or something like that, right? Those weird conversions. And if you don't get those weird conversions, it's probably because you don't understand cross-canceling. So in this, we're going to be looking at some weird conversions here in a second. So here we go. Cross-canceling. If you had something like 3/8 being multiplied, and we haven't talked about multiplying fractions yet, but we will. If you had something like 3/8 and it was being multiplied by something like 75 100 seconds, and that was being multiplied by something like 64 51sts. What we should use and could use and ought to use is this idea of cross-canceling. So what we can do is we can look at this 3, it's in the numerator, and we could see, does that 3 have anything in the denominator that it could cancel, that it could cross-cancel with? So can 3 and 8, can those cross-cancel? 8's not divisible by 3, so 3 and 8 can't cross-cancel. Let's move on to the 102. Can we cross-cancel that 3 with the 102? We're thinking not, but let's think again. 102, 1 plus 0 plus 2 is 3, and 3 is divisible by 3, so 102 is divisible by 3. If you remember from yesterday's assignment, it was 34 times 3, wasn't it? So what I'm saying here is we can cross-cancel this 3 with this 102. And not to be confusing, but I'm going to clone, not to be confusing, but I'm going to try to clone this, and we're going to cross-cancel a couple different times because it is, okay, this is just getting ridiculous now. Sorry about these little red lines. I'm about to lose my patience here with my smart board. In a minute, we're going to cross-cancel a couple different ways because you can. But anyways, this 3 will cross-cancel with this 102. Okay? So when we cross-cancel, that means we're going to divide the 3 by 3, which turns into a what? A 1. And it doesn't really matter where you write it, but you should write it somewhere so you can see it. So I'm going to write it. I always write it in the upper left corner when it's in the numerator. It's just habit. The 102, when we divide it by 3, that turns into a 34. Now down here, I might write it down on the bottom right, just, I don't know why, but okay. So that 3 and that 102 cross cancel, okay? So now let's move on to the, it's going to be a long day with the smart board if it keeps doing this crap. 75. Does a 75 cross cancel with the 8 in any way? No common factors. 75 and 34, do they cross cancel? No, because 34 is, it doesn't have any factors in common. What about 75 and 51? Do they have any common factors? If you remember from yesterday, we said 51's not prime. 51's divisible by 3. And 75 is also. So when we divide each of these by 3, when we divide 75 by 3, what's that turn into? A 25. And then when we divide the 51 by 3, that turns into a 17. Okay. So now with cross canceling, we kind of take a look at this 25 here. Does 25 cross cancel with the 8? Don't think so. With the 34? Don't think so. With the 17? Don't think so. So now we move on to the 64. Does 64 have anything in the denominator that it's going to cross cancel with? Oh, the 8. So when we divide both by 8, the 8 turns into a 1, and the 64 turns into a 8. Okay, so now we can move up to this 8. Does that 8 have anything in the denominator that it could cross cancel with? The 34, they're both even, right? Okay, so they're both even, so when we divide by 8 by 2, what do we get? We get 4, and then when we divide the 34 by 2, we get... Oh my gosh, this is so awesome! I love this example! Yes! Okay, so this is a perfect example. So, I don't know. I'm just really excited now. So 1 can't cross-cancel because 1's about as small as it gets, right? In terms of reducing. 25, does 25 have anything it'll cross-cancel with? No. Remember, numerators cancel denominators. Denominators cancel numerators. Does the 4 have anything that it could cross-cancel with? I don't think so. Can we cancel this? Can we cancel this? Come on, work with me here. Come on, smartboard. Can we cancel the 17 with the 17? No. Remember, numerators don't cancel numerators and denominators don't cancel denominators. Okay? So hopefully you kind of get an idea, a feel for how cross-canceling works. Does that make a little bit of sense? Well, is this the answer? Good question. The reason we cross-cancel is because when we multiply fractions, we multiply across the top and we multiply across the bottom. So imagine, if you would, the directions didn't say cross-cancel. Imagine, if you would, if the directions said multiply. So you would have 3 times 75, which is a lot, times 64, which is a heck of a lot more. If you had to multiply this by hand, and you will on the test without a calculator. But let's see, 3 times 75 times 64. I wouldn't want to multiply that by hand. That's 14,400. So that's 14,400 over, well, you will have something like this on the test, yes. Where you have to multiply that much, you're right. 8 times 102 times 51. But you might not have to multiply that much. I missed a 51. Let's try that again. 8 times 102 times 51. Whoa! 41,616. Oh my goodness. So the question is, well, why is cross-canceling handy? Well, yeah, check this out. If we had cross-canceled that, we wouldn't have to multiply all that out, and we wouldn't have to reduce that big fraction. That's a monster to reduce. What's your 6th grade teacher say? It's even, divide by 2. I'm not going to even try to find the LC or the GCF of those, because that's going to take forever, isn't it? But let's see. Let's go with 1 times 25 times 4. What's 1 times 25 times 4? 100, okay. So if we had cross-canceled first, the product would be 100 over, now let's look at the denominator, 1 times 17 times 17. We just had that a week ago. 289. And that's the answer. And you can't reduce any further. Here's the awesome thing about cross-canceling. If you cross-cancel as much as you can, before multiplying, you won't have to reduce later. Let me say that again. If you cross-cancel completely before you multiply, you won't have to reduce later. If you cross-cancel as much as you can before you multiply, you won't have to reduce later. So, never. So let's try this 14,400 divided by 41,616, and let's see what that is as a fraction. It's 100 over 289. Check it out. Okay? So hopefully, I really hope that you understand now that cross-canceling helps us multiply fractions, and it's not the same as cross-multiplication. Okay? Everybody all right so far? Okay. Well. We need to look at multiplying and dividing. We kind of looked at multiplying already. We'll look at it again. And I do quickly want to look at an example because I said I would. Convert 32, I said 32, I wrote 3F. Convert 32 feet per second to miles per hour. The one thing I hate about physics, and I know hate's a really strong word. I love physics. I hate about physics. They use units that don't make sense to me. I don't understand feet per second. I do understand miles per hour relatively, right? Because how fast do you walk? 2, 3, 4 miles an hour. How fast do you ride a bike? 15, 20 miles an hour. 55 if you're getting towed by a rope behind a car. Don't do it. How fast does your car go? 55, 60, 70, who knows? Maybe 100. But you shouldn't go that fast. How fast does my motorcycle go? I'm not going to comment on that one. So here we go. 32. What's the word per mean? It's what the cat says when it likes you. But it means what? It's like putting the two units together as a, what's the word per? As a fraction. Thank you. The word per, this word per here, this word per right here really means we're going to divide. Okay? Means we're going to have some kind of fraction. Okay? 32 feet per second. So the second goes in the denominator, right? Now, what ends up having to happen is we want our final units to be miles per, there's that per again. Matter of fact, let me copy that per. Miles per hour. And I don't know if your science teachers ever showed you this, or your math teachers in the past ever showed you this, but they should have. And I'm not calling them out and saying they're bad people. But I am saying if you get this, if you just bear with me for the next 2 minutes, you'll be a whiz at converting units. We need to cancel the feet, and we need to turn feet into miles somehow, right? Forget about dividing, forget about multiplying. Let's set up the units. I know you probably know the conversion rate, but forget about multiplying and forget about dividing for a second, because usually somebody screws it up somewhere. We want the feet to cancel. So in my next fraction that I'm going to have, I want the conversion rate that involves feet. 5,280. There's 5,280 feet in a mile, right? Okay. Now, if I put feet up here, that's going to screw things up, isn't it? Because numerators don't cancel numerators. Numerators cancel denominators, right? So I need to put, and you did say divide earlier, and you had that right. That's good. I'm impressed. So what we need to do is put this feet in the denominator. When we do that, the feet in the numerator will cancel the feet in the denominator, but that 5,280's got to go into the denominator, right? And what's going to go in the numerator? Well, let's not jump the gun. I want to set up a couple fractions because How many? 5,280 feet are in how much? Are in 1 mile. So notice how here my units of mile are going to make miles in the numerator. Is everybody with me so far here? I hope. So I'm going to set up another fraction, and people look at this, why do you make 3 fractions? Because it's foolproof. It never fails. It works if you use this. So this next fraction I'm setting up, now I need to convert seconds into minutes, or no, hours. 60 times 60, isn't that 3,600? So there's 3,600, and I don't know where this number goes, but there's 3,600 seconds in an hour. So you might think, well, let's put this up here. I don't know. Does it go up top or in the bottom? I don't know. Let's set up the units. To cancel out the seconds, where do I need to put the seconds? In the top. So I need to have seconds up here. So the seconds cancel the seconds. And there are 3,600 seconds in 1 hour. And that's how I would set that up. Okay. So I would take 32 times 3,600 and divide by 5280. Okay. So I would take 32 times 3,600 divided by 5280. So 32 feet per second is about 21.8 miles per hour, approximately 21.8 miles per hour. Okay. The cool thing about this is you can use it to convert any kind of units. Any kind of units. We doing all right? Somebody said we just learned that. What class did you go over that in? Kim? Sweet. Cool. Good. All right. So multiplying. Real easy. A over B times C over D is AC over BD. In other words, when you multiply fractions, you multiply across the top, you multiply across the bottom. I like to write this on people's paper when they forget to do this. It's an abbreviation. It doesn't look like much of one. Red Beth Malt. Red Beth Malt is me kindly telling you that you should cross-cancel first, or reduce before multiplying. If you had 3/8 and you wanted to multiply that by 8/21, can we cross-cancel anything there? The 8's cross-cancel, so the 8's turn into what? 8's a 1 and the other 8's a 1. Can we cross-cancel anything else? We could cross-cancel the 3 turns into a 1 and the 21 turns into a 7, and our final answer then is 1 times 1 over 1 times 7. So it's 1 over 7. Well, that's easy, isn't it? Now imagine if you had multiplied 3 by 8 and got 24, and then 8 times 21 and got, I don't know, 168, and then you had to reduce that. Do you see why you should reduce before you multiply? It makes it a ton easier, So last thing for today is dividing. This always reminds me of Pink Floyd. I think it's Pink Floyd. Does that sound right? There's that one song by Pink Floyd that talks about no dark sarcasm in the classroom. Teachers leave those kids alone. Brick in the wall, another brick in the wall, yeah. So if we had A over B and we wanted to divide this by C over D, it's kind of cool what happens. This first fraction, A over B, we don't mess with it. It's going to stay A over B. The second fraction, what we're going to do, it's actually, to be honest, it's impossible to divide fractions. It's impossible to divide matrices, so we multiply by their inverse. It's impossible to divide fractions, so we multiply by their inverse. And their inverse is oftentimes called the reciprocal in the context of a fraction. So what we are going to do is we are going to multiply by, and here's where it gets a little tricky, we got to take C over D and we got to invert it, or flip it over. D over C. Okay. Now, some people have shown you something really bad at one point in time. I don't know who, but I've seen students in the past try to do some of this crap, and it's really confusing. So I'll quickly show you what they did. If you want to see it again, you'll have to watch it in the video. But so here's an example. Let's go with 3/5 divided by 9/10. Okay. So what some people do is they say, okay, boom, boom, it's 30. And then they say, boom, boom, it's 45. And then they say, okay, so that's going to be 2/3. That's horrible. They shouldn't have shown you that. Okay. So it was 3/5 divided by 9/10. Okay. So let's set it up the way we're supposed to set it up. It's 3/5. Remember, the first one stays the same, times 10/9. Okay. And I say, if you can, cross cancel first. Not cross multiply, it's cross cancel. Cross cancel. Cross cancel. The 3 and the 9 cross cancel. The 3 is a 1, the 9's a 3. The 5 and the 10, the 5's a 1, and that's a 2. And then we get 2/3 right away. Okay? Whoever showed you this crap with the zigzag like that, it actually works. But you got to be careful, and you don't want to do it wrong, and that's why I'm not a big fan of it. This way, you're going to cross cancel first. You're going to get right to the reduced answer first. Let's try a couple more. Example, -10 1/3 divided by 2 3/8. Now I've got news for you. When you, we didn't talk about this yesterday, and we should have. When you take a mixed number and make it an improper fraction, I hope you remember how this goes. We take this whole portion, the 10, and we multiply it by 3. So we're going to go 10 times 3, and then we add the 1, right? So plus 1, and that's all going to be over what? 3. Now, if you ever have a negative, you got to kind of forget about the negative for a second, because if you include the negative, notice how I didn't include the negative when I made that conversion. If you include the negative, you're going to mess that up. Okay, so be careful with those. So 10 times 3 plus 1 is 30 plus 1 over 3. It's 31/3. Okay. If you had done this the wrong way, you would have had -10 times 3 plus 1 over 3, and you would have had -30 plus 1 over 3, and you would have had -29/3. And it's not -29/3. It's actually -31/3. Okay. It is 31/3, and it is negative, but it's not -29/3. Okay. 2 3/8. 2 3/8. What's that? 2 times 8 plus 3 over 8. 16 plus 3 over 8. So it's 19/8. Okay. So we have -31/3 divided by 19/8. Divided by 19/8. Okay. So that's going to be -31/3 or multiplied by 8/19. And this one, I don't think there's much cross-canceling to happen here, is there? So this one's pretty nasty on several levels. A negative times a positive is going to be a negative. 31 times 8, that's going to be 240 and another 8, so 248. 248. 19 times 3 is 57. And I know what somebody's thinking. Hey, yo, Mr. Minnick, that's going to reduce. Is it? If you reduce as much as you can before you multiply, you're not going to have to reduce later. So let's try this on the calculator real quick, and then that'll be it for today. So we had it was a -10 1/3. Notice how I put that in, how I put the negative out front. You've got to be real careful on those. Divided by 2 3/8. Math, let's make it a fraction. Bam, like a boss. Check it out. So that's it. It's been real. It's been fun. There's going to be a worksheet for homework tonight, and I'll see you next time.